welcome back.
Hola.
Hola, how are you doing?
Good.
Good. So today we're going to cover parts of similar triangles. The last time we were together, we talked about similar triangles, and we discovered how to state whether they are or are not similar. We did a lot of work with proportion because the sides we discovered, hi ladies, we've already started, please. Thank you. We discovered that when the triangles are similar, the sides are in proportion. We're going to be using all of that, but this time we're going to be doing it in special segments. All right, our first special segments of similar triangles theorem says this. If two triangles are similar, so you have to know they're similar before you can do this. If two triangles are similar, the lengths of their corresponding altitudes are proportional to the lengths of corresponding sides. Okay, let's get some color on here to get this to make sense. All right, so I have two triangles and I'm told that they're similar. Here are the altitudes. Please recall that altitude goes from one of the corners to the side opposite it, crashing at a 90-degree angle. Now this doesn't have to always be on the actual side. It can end up being outside of the triangle, in which case we have to extend the side into a line that goes on for forever and find that location where it crashes at a 90. You'll see that in one of our examples. For the other triangle, here is the altitude, and so our first fraction is going to be the altitude of one triangle divided by the altitude of the other triangle. And then we grab some corresponding sides. It doesn't matter which sides you choose as long as they correspond to each other in each triangle. All right, fair enough? Okay. Our second special segment is if we have two similar triangles, the lengths of their corresponding angle bisectors are going to be perpendicular, or excuse me, are going to be proportional to the corresponding side length. Okay, so here's our picture, and here's our angle bisector. Recall that angle bisector is a line that cuts one of the vertices into two congruent pieces. Okay, so there's our angle bisector, and it's going to make them in proportion. So let's look at our proportion statement. Here are the angle bisectors in one fraction with each other. And then here is a corresponding pair of sides in the other fraction. Note that that corresponding side can be any of the three sides that you want, as long as they correspond. Okay? The last one. If two triangles are similar, the lengths of their corresponding medians will be in proportion to corresponding side lengths. Remember, medians come from vertex. They run into the opposite side, and they do so at a spot where they're congruent on either side. Okay? So there are your medians. Looking at our fraction, our proportion, notice that one fraction is made up of the medians. And the other side, bless you, is made up of those corresponding sides. And again, it doesn't matter which of the sides that you've grabbed as long as they correspond to each other from one triangle to the other. Okay. Let's go ahead and work some examples. Can I zoom in on number 1? Okay. Here's number 1. First question, are they similar triangles? How do you know? Yeah, we've got two pairs of congruent angles in here. I've got this corner pair of congruent angles, and I have this other pair of congruent angles. So I know these angles are similar. What kind of line are we seeing in these triangles? You only have three options. You have the altitude, the angle bisector, or the median. Angle bisector, do I have this showing that it's cut the angle into two equal pieces? Okay. Yeah, it's median, because we've got this line and it's cutting the side lengths of the triangle into two congruent pieces. Very good, so we're dealing with median. Looking for the corresponding side lengths. These are the ones that are corresponding, because both of them go from where the median is coming from to the vertex that's marked with one congruent marking. Okay, so those are corresponding. All right, so I'm going to set up my proportion. My fraction is going to be the medians in a fraction together. And that fraction is going to be equal to my corresponding side lengths. And now I can cross multiply and solve. I'm going to need help with 20 times 18. Bless you. 360 says gentleman with the calculator. And then 36 times x is just 36x. And when I divide that, x equals. All right, and that's all I've been asked to do, is just to find the value of x. Felt okay? Nice and easy? All right, let's look at number 3. Are the triangles similar, yes or no?
Yes.
How do you know? I'm sorry, one more time? Yeah, corresponding angles are congruent. Very nice. What kind of lines do we have in these triangles? Angle bisector, do I have it cutting the angles into two congruent pieces? No, so not angle bisector. Try again. Median, do I have the line cutting the side into two congruent pieces? No, not median. Try again. Altitude, it's the only one that's left. It's the one that goes from vertex, and we have 90-degree angles sitting there. So these are altitudes. Here's our corresponding sides, because they go from where the altitude originates toward the corner with only one congruent marking. And so those are the corresponding side lengths. And so I can write my altitudes in a fraction. I can write my corresponding side lengths in a fraction, and then cross multiply and solve. Oh, yes, I'm sorry. I didn't realize I was writing off screen. Thank you. And when I divide, x has a value of 2.5 or 2.25? 2.25. Okay. Good. Let's skip over and do number 4. Okay. Number 4, are the triangles similar? How do you know? Corresponding angles are congruent. Beautiful. What kind of line are we seeing? Is this line cutting an angle into two congruent pieces?
Altitude.
Yeah, altitude, because it's crashing into the line containing the opposite side at a 90-degree angle. Okay? So, for short, the altitude is creating a 90-degree. All right, here's our corresponding sides. We actually had two corresponding sides to choose from. You could have picked this one, or you could have picked these. It didn't matter which one you picked. Going to write the corresponding altitudes in a single fraction, and then write the corresponding sides in a fraction. Excuse me. Cross multiply and solve. And x has a value of? Yeah, I don't know either. Totally calculator moment. 8.75? Okay. Okay, do y'all need to see number 2? Yes, let's definitely do number 2. It's got a slightly different setup. All right, number 2, are the triangles similar? How do you know? Corresponding angles are congruent. What kind of line is created in these?
Angle bisector.
It's an angle bisector because we have this line that's cutting these angles into 2 congruent pieces. And here would be our corresponding sides. Note that they go from where the angle bisector originates to the corner with the 2 congruent markers. Again, my setup is to write the angle bisectors together in a fraction, and then to set that equal to a fraction that's written of my corresponding sides. And then I can cross multiply and solve. Do you need to see the cross multiplication and solve again, or are you feeling okay with it? You're feeling okay? Okay, let me go ahead and zoom out. And we're on the back page. I won't finish that problem, the algebra. You can if you want. Okay, take a look at number 5 and number 6. Think through. Triangle similar? How do you know? Corresponding angles. And on number 5, what kind of lines do we have? I think you're altitudes, because we're creating that 90. And in number 6, what kind of segments do we have? Medians, because we're creating corresponding side pieces. Good. We won't run through the actual algebra of 5 and 6, because once you've identified what pieces there are, make sure you put the altitude or the median in one fraction, put the corresponding sides in the other fraction, set them equal, cross multiply, solve, you're done. Okay? All right, let's look at our very last theorem. It's our angle bisector theorem, and it says this. An angle bisector in a triangle separates the opposite side, the side opposite where the angle bisector is coming from, into 2 segments. And these segments are proportional. Again, so we can write them as a fraction and set that fraction equal to the lengths of the other 2 sides of the triangle. Now the hard part here is it's really particular about where you put the information in the proportion. So I'm going to lean heavily on my colors so that way you can see what lines need to go where. Okay? So I'm just going to zoom in a little bit. Here we go. JM is going to be our angle bisector, so there's our angle bisector JM. Now on one side of the angle bisector is a segment, we've called it KM. And then here is the other side of the side opposite where the angle bisector comes from. Okay? And we put them in a fraction. And this order doesn't matter. Okay? Which one you've put top or bottom. But now that we've made our choice, notice right here. This side that goes from where the angle bisector is originating toward the green side that I've colored, that's going to go in the top. And then here, L, this side is going to go with the side that goes toward L. Okay? So you have to make sure that these first letters of the segments are matching. All right, let's do a setup. I'm going to do number 8 so that I can keep my example up and running. All right, I've got an angle bisector. Here it is. On one side of the angle bisector, here's the other side of the angle bisector. This side's going to go with the left side of the angle bisector, and this one's going with the right side of the angle bisector. My proportion is going to be set up this way. It's 2 fractions equal each other. On the top is going to go one part of the side that goes with the angle bisector, and the other part of it is going to go on the bottom. Now if I look here, this is the green side, that's the left side, so I'm going to pick the left side of the triangle. And then the other side that I have left goes there. Cross multiply solve. And I'm writing my A's that way because otherwise they look a lot like 9s. And then it just looks weird. Alright, let's do another setup. I'm going to do number 10 so that I can keep number 8 in frame for you as a reference. Okay? Here's my angle bisector. I have one side and I have the other of the side of the triangle opposite where the angle bisector comes from. And I'm color coding the other sides of my triangle. Now this side measures 10. I don't know what this side measures, but I know that all together they measure 15. So if all together they measure 15 and this side is 10, what is this piece? Good. Alright, and now I can set my proportion. On one side of the equal sign will be a fraction that's composed of the side of the triangle that is made up of the side that the angle bisector is intersecting. And then on the other side of the equal sign in a fraction, I'm going to write the other sides of the triangle, but making sure to place them with the piece of the other side that it goes with. This is really the most complicated one to get set up, okay? Because there's so many pieces that have to go in the right order, okay? Do you need to see the cross multiplication on this? Okay, so just the setup again. All right, let's look at number 7 setup. I'm sorry? I'm not doing the cross multiplication on it. We're just focusing on the setup. All right, here's my angle bisector. Color coding the side of the triangle that's on either side of my angle bisector. And then color coding the other sides of the triangle. Again, my setup is going to be some sort of proportion, that is a fraction equal a fraction. One of my fractions is going to be these two pieces. And now my other fraction is going to be the corresponding entire sides that go with that particular piece of the side that got cut by the angle bisector. So this one is green on top. That's the left side of the intersected side. And so this is on the left of the angle bisector, and so that's in the top. This is on the right side of the angle bisector, and so this is the side of the triangle on the right side of the angle bisector. Okay, do you want to see the setup one more time? Or are we feeling okay with it? You feeling okay with it? All right, I'm just glancing around making sure everyone's feeling okay with it. Just give me a quick nod if you're feeling all right, or if you give me a head shake if you want to see a setup again. Feeling okay with it? Okay. All right, then that's all I had for you today. We'll skip that example for next time if you need it. Thank you very much.